Problem 47, page 599. A mercury thermometer is constructed as shown in the figure. The capillary tube, here we have the capillary tube of the vessel, has a diameter of 0.004 centimeter. So we can say small d equals to 0.004 centimeter. Here we have small d. And the bulb, here we have the bulb, has a diameter of 0.2 centimeter. Let's say capital D equals to 0.250 centimeter. Neglecting the expansion of the glass is very important point. Here we neglect the expansion of the gas if we increase the temperature from T initial to T final. T final equals to T initial plus delta T. Okay? Find the change in height of the mercury columns that occurs with a temperature change of 30 C. So we have delta T equals to 30 Celsius. I have to find the height, the change in height, dH. As you see, initially we have only the bulb filled with mercury. Okay? Only the bulb. Let's say this volume equals to small v0. Okay? And initial state, we have T initial, the volume of the mercury equals to V0. At the final state, the volume of the mercury equals to V0 plus V. Okay, this the volume V here plus V0. You know, here we have a volume expansion. You know the relation delta V equals to beta V0 times delta T. T final minus T initial, we can say equals to beta V0 times delta T. Okay, delta V equals to V final minus V initial equals to beta V0 delta T. We can say here V0 or we can say V initial. Okay, let's say here V initial. Here also V initial. Okay, you know V final equals to V0 plus small v. We can say V0 plus small v minus V initial here equals to V0 equals to beta V initial equals to V0 times delta T. So V0 minus V0, we get V is the volume, this one, equals to beta V0 times delta T. Me, I want to find delta H. You know, the volume of the capillary tube here equals to the section times the height. Okay, V equals to the section here, the section of this capillary tube equals to pi r square. So here we have pi r square times the height. The height equals to delta H. Okay, equals to pi 3.14 times r equals to d divided by 2 square times delta H. This is the volume V, this one, which is equal to beta V 0 times delta T. Beta is a volume expansion. You know, in the case of a solid object, beta equals to 3 alpha. But in the case of gas or in the case of liquid, I give you the value of beta. It's a given value. What is the value of V0? You know, we have a ball. V0 equals to 4 divided by 3 pi times here, be careful. We have small d here, okay? Small d. And here, pi r square, r equals the capital D divided by 2 cube. The volume of any sphere equals to 4 divided by 3 pi r cube. R equals to D diameter divided by 2. Okay, times delta H. No, this is the value of V0. Okay, I have we can write delta H equals to beta times V0 equals to 4 divided by 3 times pi times D equals to 0.250 in meter times 10 minus 2 divided by 2 cube. Okay, times delta T equals to 30. Be careful, you have to put it in Kelvin, plus 273. Okay, delta T equals to 30 C plus 273. We get here 303 Kelvin. Divided by 3.14, small d equals to 0.004 times 10 minus 2 in meter divided by 2 square. Okay, here we can eliminate pi and pi. We do the calculation. I give you the value of beta. Okay, beta equals to beta of the glass, okay? Beta of the glass. No, excuse me. Beta of the mercury. I am calculating the expansion of the mercury. Equals to 1.82 times 10 power minus 4 Celsius minus 1. The answer will be equals to 3.55 times 10 power minus 2 meter. This is the value of the height, the final height of the change of height in the capillary tube. Here, the most important point, we are neglecting the expansion of the glass. Okay? I will give you another example in the case where we have an expansion of the liquid and the vessel.